Welcome to B&D program again. Today we will discuss mole concepts. During a chemical reaction between calcium carbonate and hydrochloric acid, can we take a molecule of calcium carbonate and two molecules of HCl? No, it is not practical. So in that case, we have to think about a large quantity of calcium carbonate and a large quantity of hydrochloric acid. That means we always take them in the form of bulk. There is a large number of atoms or molecules are present in that bulk. Therefore, it is necessary to select some bigger units. For what? For counting these particles. For example, you consider the counting of money in rupees instead of paise. It is necessary to consider the amount of substance as a number which consists of a large number of particles. For that, we want the concept mole. Mole may be for counting molecules, atoms or ions. For that, we want some explanations. That is, this mole concept is related to mass of a substance. Okay, a mole of a substance is equal to its gram molecular mass. A mole of a substance is equal to its gram molecular mass. For example, you consider carbon dioxide. What is the atomic mass of carbon? 12. What is the atomic mass of oxygen? 16. Therefore, the total molecular mass of carbon dioxide is 44. 1 mole of carbon dioxide weighs 44 gram. Clear now? That means 44 gram of carbon dioxide consists of 1 mole of carbon dioxide molecules. Similarly, can you calculate the number of moles of water present in 18 gram of water? Okay, good. For that, we want the atomic mass of hydrogen and atomic mass of oxygen. What is the atomic mass of hydrogen? 1. What is the atomic mass of oxygen? 16. So, total molecular mass of water is 18. That means molecular mass is expressed in gram. That is called gram molecular mass. That is 18 gram. So, 18 gram of water consists of 1 mole of water molecules. Or in other words, 1 mole of water molecules is equal to 18 gram water. Clear now? In the case of atoms, 1 mole of a substance is equal to gram atomic mass. Example, you consider carbon. What is the atomic mass of carbon? 12. If we are expressing this 12 in 12 grams, we can say 1 mole of carbon is equal to 12 grams. Or other words, 12 gram of carbon consists of 1 mole of carbon atoms. Clear now? What is the atomic mass of sodium? 23. So, 23 grams sodium consists of dash. Can you say? Yes, okay. 1 mole of sodium. 1 mole of sodium. Now, the mole is defined in terms of carbon 12, which is considered as the standard atomic mass, and its mass is taken as 12. You know, atomic mass of carbon is 12. As per the definition, a mole of a substance is its amount in grams, which consists of the same number of molecules, atoms or ions or electrons as the case may be, as there are atoms of carbon in 12 gram of carbon 12. Once again, a mole of a substance is the amount in grams which contains the same number of molecules, atoms, ions or electrons as the case may be, as there are atoms of carbon in 12 gram carbon 12. Where carbon 12 is the isotope of carbon. You know, the last 12 is the atomic mass of carbon. In other words, a mole is the amount of substance which contain as many elementary particles as there are atoms in 12 gram of carbon 12. Once again, mole is the amount of substance that contains as many elementary particles as there are atoms in 12 grams of carbon 12. Clear now? Now you got the concept of mole. Mole is related to the number of particles. The number of particles present in 1 mole of any substance is equal to 6.022 into 10 raised to 23. In certain cases, it is considered 6.023 into 10 raised to 23 also. This number is called, yes, tell me. This number is called, tell me, Avogadro's number and is denoted by capital N. Avogadro's number and is denoted by capital N. Okay. Now, what is Avogadro number? Avogadro number is the number of particles present in 1 mole of any substance. What's its value? 6.022 into 10 raised to 23. Okay, good. The term mole can be considered for all substances existing as discrete particles, separate particles. The particles may be atoms or molecules or ions or electrons as the case may be. So, we can define the mole, the mass of substance which contains Avogadro number, that is 6.023 into 10 raised to 23 of particles such as atoms, molecules, electrons, ions, etc. and has mass equal to gram atomic mass, gram molecular mass or gram ionic mass, etc. as the case may be. 1 mole of oxygen. Thus, tell me, 1 mole of oxygen is equal to dash molecules. 1 mole of oxygen means 1 mole of oxygen gas that consists of dash number of molecules, 6.023 into 10 raised to 23 molecules. Okay. 1 mole of oxygen atoms consists of dash atoms, 6.023 into 10 raised to 23 atoms, that is equal to dash gram. Yes, 16 gram. Once again, 6.023 into 10 raised to 23 molecules of oxygen is equal to dash gram. 6.023 into 10 raised to 23 molecules of oxygen is equal to dash gram. Yes, 32 gram, because oxygen is a diatomic molecule. Here oxygen means oxygen gas. Now you got the idea that the term mole must be followed by the term atom or molecule or ion, etc. to indicate the particle under consideration. Okay. Consider another example. A mole of hydrogen atoms represents 1 gram atomic mass of it, that is 1 gram, which contains dash atoms. Fill the blank. Contains 6.023 into 10 raised to 23 atoms of hydrogen. Whereas a mole of hydrogen molecules represents 1 gram molecular mass of it. What's the weight? 2 gram. Very good. Which contains dash molecules. Yes, 6.023 into 10 raised to 23 molecules. Okay. Now you got the concept of mole. But you see, now you have related the concept of mole to weight and to number. But how to connect the concept of mole into volume? That is, what is the volume concept of mole? At NTP, that is normal temperature and pressure, that is 0 degrees Celsius and 76 centimeter of mercury pressure. At NTP, it is found that in the case of a gas, the volume occupied by 1 mole of any gas at NTP is 22.4 liter. Take 1 mole of carbon dioxide at NTP. What will be the volume of that carbon dioxide now? 22.4 liters. You take oxygen. You take 1 mole of oxygen at NTP. What will be the volume of that oxygen gas? 22.4 liter. Take 1 mole of hydrogen gas at NTP. What will be the volume of that hydrogen gas? 22.4. That means, in the case of a gas, the volume occupied by 1 mole of any gas at NTP is dash liters. Dash liters. Fill the blanks. 22.4 liters. And it is called gram molecular volume. It is called gram molecular volume. Thus, we can say a mole of any substance in the gaseous state is equal to the gram molar volume of the substance. at NTP. Thus, a mole of any substance in the gaseous state is equal to the gram molar volume of the substance at NTP, that is 22.4 liters. Now we got the clear picture of mole, and you have to say the answer for my questions. You have to find out the answer. Consider 1 mole of carbon dioxide. Consider 1 mole of carbon dioxide. Express it in gram. Yes, the symbol 44 gram. Okay, good. Express it in volume at NTP. Yes, okay. 22.4 liters of carbon dioxide at NTP. Clear now. Express it in Avogadro's number. Yes, that is 6.023 into 10 raised to 23 molecules. 1 mole of carbon dioxide molecules is equal to 22.4 liters of carbon dioxide at NTP is equal to 44 gram carbon dioxide molecules is equal to 6.023 into 10 raised to 23 molecules of carbon dioxide. Consider oxygen. 1 mole of oxygen gas is equal to dash liters. Yes, fill the blanks. 22.4 liters at NTP. Now you got the concepts. As a conclusion, we take an example nitrogen. 1 mole of nitrogen is equal to, number 1, 6.023 into 10 raised to 23 molecules of nitrogen. Number 2, 2 into 6.023 into 10 raised to 23 atoms of nitrogen, because nitrogen is a diatomic gas. Number 3, 1 gram molecule of nitrogen. Number 4, 28 gram of nitrogen. Number 5, 2 moles of nitrogen atoms. Okay. Number 6, 2 gram atoms of nitrogen. Atomic weight is expressed in gram. Number 7, 22.4 liters of nitrogen at NTP. I think it is clear to you now. Are you satisfied? We will do some problems and entrance questions later in another class. For more questions, conceptualization and explanations in chemistry, you subscribe the channel SPCL Bonds. Thank you very much.